Clean air is vital to our health. Specific gases and particles in the air can degrade the air quality and impact our health in many ways. These gases and particles become an issue when they concentrate in the lowest level of the atmosphere that we all live in, called the troposphere.
One of these gases, called ozone, is harmful when it's concentrated in these low levels of the atmosphere. This is what Dr. Gregory Jenkins, a professor of meteorology and atmospheric science at Penn State, has been studying over the past 20 years in the continent of Africa. One of his findings is that lightning can play a role in forming this tropospheric ozone.
What I've learned is that, it's a major contributor. It's highly variable in terms of the amount of ozone is being produced. It depends on the wind flow. The meteorology is really important, but at the end of the day, it's a big source, a significant source of ozone over the tropical Atlantic.
In the broad scope of the tropical Atlantic, Dr. Jenkins has been comparing lightning-forming tropospheric ozone in the United States versus Africa.
We know over the U.S., for example, that there have been field campaigns which show when you have lots of lightning that you see ozone downstream. And that's what we found over Africa. And so Africa was a place where we didn't really know if that was the case or not. But it's turned out to be a really good source of lightning.
With this abundance of lightning, Dr. Jenkins has been able to study the process of how lightning forms tropospheric ozone.
So again, what happens is that lightning flash is so hot that it breaks up oxygen, molecular oxygen, and nitrogen. And so NO forms very fast, and NO, if you put it in sunlight, so it's nitrous oxide, or people call it NOx, put it in sunlight, it produces ozone. So that's one of the reactions that will come out of it.
After analyzing the seasonal changes of West Africa, Dr. Jenkins found that during the wet season, there are no artificial pollution sources.
So everything is being produced naturally. So it's got to be lightning that's producing the ozone that we see.
Dr. Jenkins measured the ozone concentrations using ozone sondes and radiosondes to track how the winds move ozone around. A large enough ozone concentration near the ground can cause numerous health problems, especially with people who have pre-existing breathing problems.
But ozone isn't the only source of bad air quality. Dr. Jenkins also studied the role of dust storms and their impact on poor air quality in West Africa.
So we've been trying to understand how much dust in particular is contributing to poor air quality. And it turns out in West Africa that it is a big factor. It is much bigger than normal pollution.
Compared to other sources, we asked Dr. Jenkins what he thinks contributes the most to poor air quality.
To me, dust has the biggest impact. And those dust storms last probably for 1 to about 4 days. And I know people in West Africa, when they happen, if you're asthmatic, it has a horrible impact on you. You feel it quickly.
Since dust plays such a big role in poor air quality, it has a major impact on people's health at any age.
And these are very big and small particles which go deep into the lungs and very unhealthy for children whose immune systems are still developing. So a recent study showed that these small particles are related to infant mortality.
In addition to the particles themselves causing health issues in Africa, what's on them can cause problems in other parts of the globe.
We have been trying to understand if there are fungi or bacteria or viruses on the dust particles, because these dust particles from the Sahara can make it all the way down to the U.S. or to the Caribbean in the summertime, and we found those. We found that there's bacteria and fungi on those particles.
Finally, there's one other source of pollution that Dr. Jenkins has studied during his time in Africa.
You also have biomass burning. People burn their fields. The air quality is very bad. The particles are very small. So dust particles are mineral. Okay, they've got sharp edges. Biomass burning is carbon-based, and they both are bad. So it's like one is like smoking cigarettes, the other one is like throwing glass at someone. Neither are good for the lungs.
With all three of these different pollutants, air quality can really suffer and cause major health problems globally.
Pollution in general, it's known by the World Health Organization, is responsible for 1 in 9 deaths globally. So when you go to these regions where you have a lot of it and you don't really know how many people it's hurting, you need to figure out how to, for me, bring my knowledge to the field and to use that to help communicate the threats and also to quantify what we think is happening.
Dr. Jenkins also realizes that a problem of this magnitude must be solved by using multiple disciplines.
And normally, the most difficult problems take more than one discipline to solve them. So that's really the real key, I think, going forward.
Understanding these large-scale air quality issues is vital for Africa so that people's health does not suffer. Over the 20 years that Dr. Jenkins has been doing his research, he has realized that this major pollution problem cannot be solved in the short term. He views this issue as an open frontier for more research to be done to better understand the sources and effects of poor air quality. For Weather World, I'm Jacob Morris.
And I'm Joe Speir.